Hi there, juniors. I just want to run this quick video by you to add some support for your completing of the half-life nuclear decay lab with the barium-137. First of all, you've got your data and you have recorded some values of the background radiation and calculated the average background radiation. Don't forget to subtract the background radiation value from all of your count values. Every one of your data values also includes that background radiation, and it needs to be taken out, just like in your exam questions. Subtract that before you can find out the half-life of the sample. Okay, so on your graph, you will have the identical graph as your partner does, but now you're going to start working independently. So you're going to print out your graph or do this digitally. You need to pick a point on the actual line of best fit. So there's that line of best fit on again, I'm just sketching this roughly for you, and you're going to make a nice, pretty formal version to hand in. But here we go. So you've got a value here of your counts per minute. In this case, I just labeled it 240, and then half of that is 120. We go to 60, 30, and you get 4 different times: 240, 120, 60, 30. And then as you draw a line on your graph, again, either digitally or with a ruler and a pencil, then you can meet that graph and drop a line down, and that will be your time. You'll need 4 landmark times to get 3 intervals: time 1, time 2, time 3, and time 4. And you can label them as such on the x-axis. All right, then you're going to make a little table. Again, yours will be formally typed up, and mine's just sketched on this pad. But you're going to make a table of half-life landmark times. And you'll write them all down there. Maybe 5 seconds in this example, 20 seconds, 34 seconds, and 50 seconds. Those are not half-lives. Those are just landmark times. To get to half-life, of course, you need the interval between those times. So you'll write down this equation, the half-life sample calculation. It's very simple. The half-life, the first one, equals T2 minus T1. And then right below that, look at those equal signs vertically aligned. You will type in the data values: 20 seconds minus 5 seconds. That gives you 15 seconds. That is the half-life value. The next one over here, rather, is going to give you 34 minus 20. That's going to be 14 seconds. The next one, 50 seconds minus 34. That's going to give you 16 seconds. And you can write those down in the next table of calculated half-lives. But you only have to provide one sample calculation of the half-life with the equation, with the data in units, and then with the answer. Nice. And now we're getting on to it. The average half-life calculation, that's a titled calculation. You're going to show the average. You're going to have to calculate the average half-life. Here it's simple. I've chosen nice numbers: 15, 14, and 16. You can see with your eye that the average is going to be 15, but in your lab, you need to show me the the average value formula, which is the sum of all the half-life values divided by the number of them. And there it is right there. After you type in the formula, then you can type in all the data with units right below that. So there's my 15 seconds, 14 seconds, 16 seconds on the top divided by the number of values, which is 3. These are all the half-lives. So the average half-life comes out to 15 seconds. And then moving on from there, I've just made up this, of course, you're working with barium-137. But I'm using an example of Gregium-139, whatever. And the published value, you're going to look up the published value of barium-137 and find out what that is. And you can write that down. And then you're going to write down your experimental value as such and label it that way. And then you're going to do a percent difference calculation. Sorry, that got erased. This says percent difference calculation. And you need to show the formula for that, which is quite simple. The percent difference is the absolute value of the experimental half-life minus the published half-life all divided by the published half-life, multiplied by 100%. Then you put in your data with the units, multiply that by 100%, and I don't even know if this calculation's right, but there it is. For example, you'd get some number like 2 or 10% or 20% or 1%. And there's your happy face because you're done. Don't forget, wherever you get your published value of the half-life from, you should have a little citation. Can I write that on there now? Citation. There it is. That's not easy to do. Okay. In other words, the URL, the source, NASA, your textbook, wherever you find it from. And if you do all those things, then you should be in good shape. Thanks for watching. Whoop.